Hello everyone, I'm Sebastian Y, and this is Foundations of Economics. In this video, we are going to talk about demand. Demand gives us the relationship between price and the quantity demanded for a particular good. Quantity demanded is the quantity that an individual buyer or a group of buyers is willing to purchase at a specific price. There are definitely other factors that go into a person's decision to buy something, but we are going to be thinking about the price, ceteris paribus, meaning we are going to hold all those other factors constant and just focus on the price for now. One of the simplest ways to represent demand is with a demand schedule. On the left of the screen here, you can see an example demand schedule for a buyer named Bill, and we'll think about his demand for pizza. When the price is low, Bill is willing to buy a lot of pizza, and as the price goes up, he's willing to buy fewer and fewer. This is one of the characteristics of demand. There's an inverse relationship between price and quantity demanded. The higher the price, the lower the quantity demanded. The lower the price, the higher the quantity demanded. One thing I'm going to be emphasizing throughout this whole course is the relationship between graphs and math. We can see all the numbers in the demand schedule, but we can also represent that on a graph. In economics, supply and demand graphs always have quantity on the horizontal axis and price on the vertical axis. I'll point out now that this is a little bit backwards from what you usually expect in a graph. Usually we think about the independent variable on the horizontal axis and the dependent variable on the vertical axis, but in econ, for some reason, it's flipped. Keep that in mind when we're thinking about the slope of these curves. Let's graph a few of these points on the axis. Starting at the top of the schedule, price of 0 and a quantity demanded of 20. At a price of 1, we have a quantity demanded of 18, and we can keep doing this all along our graph, up to the point where we finally have the price so high, in this case 10, where Bill is going to demand 0 units. Throughout these videos, I'm going to try to be as consistent as possible and always use a blue line to denote our demand curve. I'm going to link up all of these points. That's going to be our demand curve. Now, when you draw one of these graphs, we're always going to want to label our demand curve because we're eventually going to have other things going on in this graph, so we need to make sure that we can keep things straight. So I'm going to always write a D next to my demand curve. If you're drawing this along with me, make sure that you label the two axes with price and quantity, or just P and Q if you want. In the last video, we mentioned that a competitive market is made up of many buyers and many sellers. That means the demand curve of an individual person is not going to be enough. We're going to need to get the demand curve for the entire market. To do this, all we need to do is add up every buyer in the market's demand curve to get the market demand curve. To see how this works, I'm going to add a second buyer in the market named Ted. The schedule on the left shows the individual demand schedules for both of our buyers, the quantity demanded that each of them will demand at each price. You can see that Ted behaves much in the same way as Bill. At low prices, he has a high quantity demanded, and at high prices, he has a low quantity demanded. This is the law of demand. To get the market demand schedule, we need to find the quantity demanded for the entire market at each price. To do that, all we need to do is add up the individual quantity demanded for each person. We'll start at a price of 0. 20 plus 30 is 50. 18 plus 27 is 45. 16 plus 24 is 40. And we can continue this down. Let's see how this looks on the graph. I've gone ahead and used the computer to graph Bill and Ted's individual demand curves. Let's do the market demand curve together. At a price of 0, we can see that Bill is at 20, Ted is at 30, so our total, of course, is going to be 50. And we can go from there. At 1, we have 45, and so on. As before, I'm going to use a blue line to mark out our full demand curve. And I'll label that with a D for our market demand. You can see that as we add buyers, it's going to add up horizontally because quantity is on the horizontal axis. Another point you can see this is at a price of 5, we've got Bill at 10, Ted at 15, and so our market demand is going to be at 25. Let's talk about a third way to represent our demand. We've talked about the demand schedule, as you see in front of us, and the demand curve on the graph. The third way that we can do this is with a demand function. The demand function is a mathematical equation that tells us the relationship between the price and the quantity demanded. I want to point out again that this is the exact same thing as the schedule and the curve, it's just another way of writing it. The demand function for our example market demand is QD, and I'm always going to use this superscript D to make sure that we know this is the quantity demanded, equals 50 minus 5P. P is the price. If we plug in some of the numbers, we can see how this works. For example, if the price is 4, we can plug the 4 in and get 50 minus 5 times 4. That's going to be 50 minus 20, which is 30. And you can see that 4 and 30 appear on the same line in the demand schedule. Now, how do demand functions relate to demand curves on the graph? If you are just given a demand function and asked to graph it, the easiest way to think about this is, what are the intercepts? That is, finding this point right here and this point right here, and then from there, if we know that it's a straight line, which it is here, we can just draw that line. The quantity intercept is the easier one. What is true of the price at that point? Well, the price is 0. So we can simply put a 0 in for the P and get 50 minus 5 times 0, which is just 50. That matches up with our intercept. To get the price intercept, we need to think, how high would the price have to be to get the quantity demanded all the way down to 0? So we can plug in 0 for the QD equals 50 minus 5P. Just do a little bit of algebra here by adding the 5P over to both sides, dividing both sides by 5, we get P equals 10, and that is exactly what we see here. Once we know those 2 points, mark those off on your graph, draw the line between them. We can also see here that the slope of our demand function is negative 5. That means that every increase of the price by 1, the quantity demanded goes down by 5. For example, let's just say we had a price of 4. We can see that the corresponding quantity here is 30. If the price were to go up by 1, from 4 to 5, what happens to the quantity moving from this point to this point? Well, it goes down by 5. This is a little bit tricky for the reason that econ graphs are flipped in a sense, where what we typically would think of as the x and y variable are reversed. But just remember, the quantity is on the horizontal axis, price is on the vertical. So far, what we've been talking about is price ceteris paribus. We just looked at what happens if we were to increase the price by 1, but keeping all of the other factors constant. When we do this, we are moving along the demand curve. Increasing the price moves us up and to the left on the demand curve. Decreasing the price moves us down and to the right along the demand curve. But we're just moving point to point along the curve. We're now going to open things up to think about what happens if some other factor changes. What that's going to do is shift the entire demand curve. I'm going to draw a fresh graph to demonstrate what we mean. When we draw one of these graphs, make sure we label price and quantity on the appropriate axes. I'll draw in an example demand curve. When demand shifts, the entire curve is moving to the left or to the right. An increase in demand is a shift to the right. If I draw a new demand curve in, I'll just call that D prime. We can look at any given price, let's say this one right here, and we can compare the quantity demanded at the old demand curve to the quantity demanded on the new demand curve. We can see that at the same price, there's now more quantity demanded at that same price. Likewise, we can look at a shift to the left, that's a decrease in demand, and we can see that at that same price, now a lower quantity is demanded. So always think about this in terms of shifts to the left and to the right. We're now going to think about some factors that can shift the demand curve. First is a change in income. Income, of course, is directly related to purchasing power, and that, of course, is going to change the behavior of buyers. The specific relationship of income to demand is determined by whether the good we're looking at is a normal good or an inferior good. First thing I need to point out here is that these are English words that we use all the time, but the econ definition of these words is very specific. A normal good is one where if our income goes up, we consume more of it, and if our income goes down, we consume less of it. An inferior good is the opposite. If our income goes up, we consume fewer of the inferior goods, and if our income goes down, we consume more inferior goods. So this does not mean normal versus abnormal, and it does not mean inferior as in bad. It just means that we tend to buy less if our income goes up. Whether a particular good is normal or inferior to you might be different than someone else. And it might also depend on what is your current income. So for example, if we took a person who has quite a low income, then bus tickets might be a normal good. As their income goes up, they feel that they can travel more and take the bus to different places. But as their income continues to rise, they might start to view bus tickets as an inferior good. Why? Because they might start to switch over to plane tickets. The plane tickets become a normal good, the bus tickets become an inferior good. Their income goes up, they start to fly more, they take the bus less. We might increase their income so much that those plane tickets they used to buy become an inferior good themselves, and the new normal good might be first-class plane tickets. The second category of demand shifters we're going to look at is the price of related goods. So far, we've only been thinking about consumers who buy one thing, but in reality, that's not the case. Everybody buys lots of different things. The price of one of those other goods might change, and that could affect a person's buying behavior of a different good. What exactly the change is going to be is determined by the relationship between those goods. Substitutes or complements. Substitutes are goods that serve similar purposes to each other and can be interchanged. An example might be Coke and Pepsi. If a price of a good increases, people will buy less of it, that's the law of demand, and instead they will buy more of a substitute. Likewise, if the price of a good goes down, people will buy less substitutes. So if the price of Pepsi were to increase, people would buy more Coke instead. Complements are goods that tend to be used together. Goods that are more than the sum of their parts when we have them at the same time. An example of this would be bagels and cream cheese. When the price of a good goes up, you're going to buy less of that, but you're also going to be buying less of its complements because those complements are not worth as much without the other good. For example, if the price of bagels were to go up, you would buy less bagels, but you would probably also buy less cream cheese. Remember, as we're talking about these demand shifters, when we talk about buying less or more of something, we're talking about a shift of the entire demand curve to the left for a decrease and to the right for an increase. Third consideration is taste. This is the least quantifiable of all the ones we're going to talk about here. But ultimately, taste determines whether or not a person wants to buy something, and this is something that can change over time. For example, the taste for cigarettes has decreased over the years as the health risks associated with smoking have become more known. What this has done is shift the demand curve for cigarettes to the left over the last few decades. Although this is sometimes something that can just happen on its own, Firms can also have an influence on this by advertising. By advertising, they might be able to increase the taste for their own product or decrease the taste for their competitor's product, shifting those demand curves to the right and to the left. Next, we can think about expectations. Do we think that the price of a good is going to go up or down in the future? If the price is expected to go up in the future, demand right now will shift to the right. It will increase because people are going to try to stock up before the price increase. Alternatively, if the price is expected to go down, people might hold off on their purchases, shifting the current demand to the left. A good example of this happened in Denmark in 2011. The government announced that they were going to put a tax on foods that are high in saturated fats. This resulted in a sudden shift to the right of the demand for butter. The last consideration is the number of buyers. We already showed that increasing the number of buyers is going to shift the demand curve to the right when we added Ted to the market that just consisted of Bill before. If we continue to add buyers, we would continue to add those on horizontally, shifting the demand curve to the right. Alternatively, if for some reason the number of buyers decreased, that would shift the demand curve to the left. Thinking about this, immigration might be a reason why the demand curve shifts to the right, if there's just more people who are able to buy things. That's where we'll leave it for now about demand. In the next video, we will talk about supply.